Halt. Put your hands up or you will be shot. 5, 4, 3, 2, 1.
Yeah, so I'm gonna build an automated airsoft gun turret. It is dangerous and illegal to install booby traps in your home. Do not do it. This video exists for the express purposes of entertainment and general engineering education. Take all necessary precautions when handling airsoft guns. They are not toys. Alright, now that that's out of the way, the design is simple enough. I'm gonna have a Kinect, which is communicating with a desktop app. And it's going to be tracking a person, and then the app is going to figure out, based on where that person is located, what angle they are relative to the Kinect, and it's going to send that information over to a microcontroller, which is going to convert that data into PWM signals and pass it over to a set of X and Y servos. So one of them can rotate this way, and one of them rotates this way. And sitting on top of that will be our gun. And I'm also going to figure out some way to tell the gun to fire when it needs to. Like I said, pretty straightforward. The only tricky part is going to be figuring out what the angles are that I need to send here. Probably a relay here. This time around I went with the Adafruit Metro Mini for the microcontroller. And I have this pair of servos with some brackets mounted so you can get one to rotate in the X direction and another to rotate in the Y direction. You can actually buy this whole thing as a kit with the brackets and the two servos, and links for all the parts will be in the description below. This is the gun I'm going to use. It's an electric airsoft gun, pretty much the cheapest one I could find. I got it from eBay. It came with a rechargeable battery, and I think this will be suitable to power the servo motors. I specifically wanted an electric gun because I plan to make some modifications. You can see through here that there's a motor on the inside, and I'm pretty sure that all that happens when you pull the trigger is that it connects the circuit, so the motor's connected straight to the battery, and then it'll start firing. My plan is to totally bypass the trigger and instead use a relay so that I can just send a signal from my software telling it to start firing the gun. So let's get this thing open and see what's on the inside. There's the motor connected to a gear system. If I get the trigger out of the way, it looks like that's actually just flipping a switch. As I mentioned, I'm just going to do away with the trigger entirely. Pull these wires out from here to connect them to a relay. And depending on how things are looking, I may even cut some of the extra plastic off of this thing to make it fit a little bit better on the servo motors. I'm pretty sure the servos are going to be strong enough to move this thing. Well, we'll find out. Since I want to use the battery to connect to other stuff too, but I still want it to be able to charge, I'm going to take this end to connect to the breadboard. And hopefully I can get this thing back together. I'm going to be using the Kinect version 2, which is the one that goes along with the Xbox One. The Kinect is actually a pretty cool device, and it's kind of a shame that they went defunct. There is a replacement version on the market now that they call the Azure Kinect, something like that, but it's more expensive and just doesn't really seem as consumer friendly as the original Kinects. You see, this thing is more than just a color camera paired with an infrared camera. There's a whole SDK that goes along with it that handles body tracking for you, as well as a few other things. And it makes it really easy for you to access that data. It gives you real-world coordinates of all these different joints on your body so that you can detect gestures and things like that. And the coordinates are simply in meters, the X, Y, and Z position, with the Kinect sensor being 000. So even though the Xbox Kinects are no longer officially supported by Microsoft, if you have any interest in doing projects that involve tracking a person or detecting gestures, or anything that involves detecting objects in 3D space, I would suggest trying to pick one of these up on eBay or GameStop or wherever you can find it before they are totally off the market. We're going to look at this in 2 dimensions. Imagine this is a top-down view, and this point K is where the Kinect is located. And somewhere out here is a person that we track. And the Kinect is going to tell us some data about this tracking person. We have the X, Y, and Z coordinates of where this person is located. And because we're looking at this in a top-down perspective, we're going to ignore Y for now, and we get X and Z. And if you imagine a vector pointing to the person here, and we'll call this angle theta. And using some basic trigonometry, we know that theta is going to be equal to the arctangent of X over Z. But we're actually not done yet, because our turret is not going to be located exactly where the Kinect is located. Instead, it's going to be located at some point off to the side. Let's say it's here. T for turret. Now we have some distance that we will call D, and a new vector to our person, and we'll call this one theta sub t. So now this is the actual angle that we need to calculate, and it's not so bad because that one's just going to be the arctangent of X plus D over Z. Now note that I didn't call this value here X, because really I just drew this axis kind of arbitrarily. The Kinect is really going to be our origin point, so the X is actually relative to this. Just to make that more clear, K is at 0, 0. So anyway, there you have it. This is all we need, and we could do the exact same thing in the YZ plane to get the Y offset and figure out the angle vertically. So I'm actually going to want to build something to mount both the Kinect and the turret at a known distance, so I always know this D. Here's the whole thing rigged up. So I've got the microcontroller and the wires for each servo. Connect the battery right here. Relay to control firing. The gun is really just rigged up with a bunch of zip ties, but it gets the job done. Zip tied a laser pointer to it, and of course the other side has the Kinect. The way it works is when it's not tracking anything, the gun just points straight ahead, but as soon as it starts tracking a person, the gun starts aiming towards their heart. Yeah, it's not perfect, the way that the servos can barely hold up the gun and the gun is just zip tied on the top of the servos, but we're going to ignore that for now. Then the device issues voice commands telling the person to put their hands up. If they do, it will continue tracking them, but it will not fire. But if they put their hands back down, it will go back into an armed mode. It'll give a countdown before firing, and if the suspect hasn't left or put their hands up, they'll get shot. let's take a look at a scenario featuring a compliant intruder.
Halt. Put your hands up or you will be shot. 5, 4, 3. Good. Now leave. Put your hands back up. Good. Now leave.
Now let's see what happens when the intruder doesn't follow the instructions.
Halt. Put your hands up or you will be shot. 5, 4, 3, 2, 1.
Note that the privacy filter, which obscures the intruder's face, is not a post effect. I'm actually using the Kinect's tracking to figure out where the head is and stick some randomly generated noise over that portion of the image. I did attempt to implement a blur effect for that, but it's very computationally expensive and I didn't feel like spending the time to do it properly. So I scrapped it. And all these other dots are just highlighting key tracking points on the intruder's body. Now let's just say that you set this thing up in your own compound to stop intruders from busting in, but then when you come in, you don't want to risk getting shot and you don't want to have to walk around all the time with your hands up. In order to solve that problem, I added a secret gesture that will deactivate the entire turret until it detects a different person, and then, everything's back on. And what, might you ask, is that secret gesture? Well, of course, double finger guns. Let's see it in action.
Halt. Put your hands up or you will be shot. 5, 4, 3. My apologies. Welcome, comrade.
For debugging purposes, I also simulate a serial console. If I press F1, I can open that up, and then I can see any messages that are getting sent to the Unity app from the Arduino, and I can also directly send messages to the Arduino. This time around, I'm not going to go through the actual code. However, I will show you what I'm doing in my Unity app. This is also not a Unity tutorial, but just so everybody's able to follow along, I'll give a quick overview. This is the scene view. It shows all the objects that I'm working with. This is the game window. It shows what's actively playing when we're in play mode, which I'll start now. This is the hierarchy. It shows a list of all the objects in the scene. This is my project folder. It shows all the assets I have to work with. And this is the inspector, which shows details about the selected object. So I started by importing this Kinect SDK Unity package, and in addition to the SDK to get everything working, it included a sample scene and some sample scripts. So I just took some of that stuff and looked at what they were doing, and then branched off to make my own thing. All the scripts that I wrote are here in the scripts folder, and the other key assets that I added are these audio files for the voice commands. So in my scene, I have this person tracker object. And what it does is look through all the currently tracked body parts in the scene, which are called joints. And it contains this list of tracked joints where I can specify specific joints that I want to somehow highlight in the camera view and notify other scripts about whenever they're updated. And the motor controller is another important object. So it's got a script called motor controller that's keeping track of these various names of joints. It has a few settings. And this is actually where I plug in that offset from the math that we did earlier on the chalkboard, telling it how far away the turret is from the Kinect. And what this thing is doing is listening for any time one of those tracked joints gets updated from the person tracker, and based on that, it'll figure out what state it needs to be in, and then it will send angle data over to the Arduino and possibly data about firing. There's also this voice command controller script attached here, and all this thing's doing is listening for updates to the motor controller state, and based on what it changes to, it may or may not play a new voice command. I also have this object called serial with a serial communication script on it that I wrote. This opens up a serial port to the name specified in this field, and this is what is used to actually send the bytes from this app to the Arduino. There's also a video feed object that has a video feed script, and it's figuring out what needs to be displayed on the screen, and then it's sending that texture over to this guy here, video feed renderer, which just paints the texture onto a raw image. And then I've got this console object, which just has a script that listens for any messages received from the Arduino and sticks those messages on a UI element. That's basically it. If you want to actually learn how the code is working behind the scenes, I'm going to put a link to a GitHub repo in the description, so feel free to check that out. This thing probably could use some improvement. The gestures are like as bare bones as they could possibly be. So they're pretty finicky sometimes. And the servos are just barely strong enough to move the gun, and not really strong enough to handle the spring force when it's attempting to fire. So there's tons of room to make this thing better. If anyone wants to grab the project and improve it, let me know down in the comments. And don't forget to like and subscribe, or this thing will find you and shoot you.